S-Chan presents Educational Video Lectures. Difficult concepts made easy. Study anywhere, anytime.
When a particular situation depends on more than one variables, then this type of situation can be observed in terms of partial differential equation.
If you want to study this topic in detail, refer to the book by S-Chan Publishing. Link is provided in the description box.
Welcome to S-Chan Academy. I am Dr. Neelam. We'll be taking this lecture on partial differential equation and its first order partial differential equation. So let's start with the situation when the situation is depending on more than one variable. So we have already discussed these things in terms of independent variable and dependent variable in the lectures of ordinary differential equations. So now we said that any situation is depending on more than one variables. So these more than one variables are called as independent variables. So to begin with partial differential equation, partial differential equations. We have independent variables on which the particular situation is depending. They are called dependent variables. And of course, they will be more than one for the formation of a partial differential equation. And now, the situation will be described in terms of an unknown function. So this unknown function. So let us say that this independent variables are x, y, and they may be any, more than one. And let us say that unknown function has been described by u. So this u will be denoted as u as a function of x, y. Now if we would like to differentiate this u, then it will be depending on two variables, that is x and y. Therefore, an ordinary derivative cannot be taken for this. So we have to take the partial derivative, and when the equation will be written where this independent variables, this unknown functions and their partial derivatives are involved, that is called a partial differential equation. So if we represent this in terms of a function, so if it is a function, it involves all the independent variable. Let us say we have two independent variables x and y. Then it involves the unknown function, that is u, and then it involves the partial derivative of u with respect to x and with respect to y. This is, and if it involves only first order derivative, it will be called as a first order differential equation. So it can involve more derivatives of u with respect to x and y. And if such an equation is written, this will be called as a partial differential equation. So we can conclude that a partial differential equation is an equation which is written in terms of all the independent variables, the unknown function, and the partial derivative of this unknown function with respect to these independent variables. So if we have, as we said, that if we have u as our unknown function and x and y are the partial this independent variables, then we know that the symbols for partial derivatives, let us revise that because we need to use them again and again, derivatives of u with respect to x. Suppose we are taking derivative of u with respect to x, so it will be taken like this. And we know that when we are taking derivative of u with respect to x, we are going to consider y as constant. So this can also be represented as ux, where x will be written as a subscript. And then these x, y are the variables for which the u has been a function. Now similarly, del u over del y, when we are taking partial derivative of u with respect to y, this will also be represented as uy, where y will be written in the subscript, meaning that we are taking the derivative of u with respect to y, and where this whole thing is a function of x and y. Similarly, when we are taking second order derivative, so it will be del square u over del x square, it will be written like this, and then this double x will be there, it will denote that a second order derivative of u has been taken with respect to x, and which again is maybe a function of x and y. Similarly, if we have two independent variables, then there will be three derivatives of second order. So it is like u x x x, then we have del square u over del x del y, which will be represented as uxy, and it is xy. It is a function of xy. The third derivative of this u with respect to y will be del square u over del y2, and it will be represented as uyy, and this is xy. We should note that if we are taking del square u over del y del x, it will be written as uyx, and which will be a function of xy. So similarly, the third order derivative and higher order derivative of u with respect to the independent variables will be written. So now it is clearly understood that this part will be denoting the order of the derivative. That is, this will be the second order derivative, and if we have del u by del x, this will be the first order derivative. So when we are writing down a differential equation, say f, where x and y are the independent variables, and then u is the unknown function, and now we can write it as ux, uy, uxx, uyy, uxy, and this, of course, this is equal to 0. So such a equation will be called as the partial differential equation. This will be called as the partial differential equation. Now, we should talk about the order of this partial differential equation. It is very clear, since we have already discussed this thing for ordinary differential equation, so same thing will be applicable here as well. The order of the highest order derivative will be the order of the partial differential equation. So if such a differential equation is there, then order of this will be 2. So 2 will be the order of the this differential equation, because the order of the highest derivative is 2. Now if we write this uxx plus 2uyy plus ux plus uy plus 3u is equals to 0, and if we ask that what is the order of this differential equation, so order of this differential equation is 2. Order will be 2. Similarly, if we have differential equation, partial differential equation like this is equal to 2u, then this will be called as first order partial differential equation. So for this, the order will be 1. So this is first order partial differential equation, and this is second order partial differential equation. So now we are well versed with that when an equation is called a partial differential equation, what is the order of this, if it is linear, quasi-linear, semi-linear or non-linear. So we have done this much in this part. In the second part of the video, we will be trying to find out the solution for a linear first order partial differential equation.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy. So in the second part of the video, we will see that how to solve a linear first order partial differential equation where both the derivatives are involved or one of the derivative is involved. So next we will discuss that when do we call a partial differential equation a linear or non-linear. So like the ordinary differential equation, a partial differential equation will be called linear if the unknown function and its derivative are linear in nature for any differential equation. So suppose we have this uxx plus uyy plus u is equal to 2x, let us say, if such a differential equation, partial differential equation is given, then it will be called as a linear partial differential equation. On the contrary, if the term involves like this, uyy plus u square, or say this also, and this equal to 2x plus 3y, if such a partial differential equation is there, because there is an involvement of non-linear terms of the derivative of unknown function, either of the unknown function or its any of the derivative is non-linear in nature. Therefore, such a partial differential equation will be called as a non-linear partial differential equation. Unlike ordinary differential equation, because ordinary differential equation can be classified into two broad groups, linear and non-linear. So here, instead of linear, non-linear, there will be two more type of classification can be made for partial differential equation. So one is quasi-linear partial differential equation, and another is semi-linear partial differential equation. So what is the difference in that? Now we will talk about strictly about the first order differential equation for this to make them clear. Quasi-linear partial differential equation and semi-linear partial differential equation. So if the differential equation is written like this, f of x, y, u, and its first order derivatives are involved, this equals to 0. If such a partial differential equation is there, then it will be called quasi-linear if this ux plus uy type of terms are there on the left side, and the right hand side is involved as fxy and u. That is, the term containing u has been taken to the right side, and ux and uy are strictly linear in nature, then this will be called as a quasi-linear partial differential equation. Now, on the contrary, if ux plus uy is equals to fxyu, and here the condition is that they should be linear, but there is no restriction on this u that it has to be linear. This may be non-linear also. So then in that situation, when this right hand side, this function, this u can be non-linear, then this will be called as a semi-linear partial differential equation. So basically, partial differential equation can be categorized, can be divided into four categories: linear, non-linear, and in between linear and non-linear, it is quasi-linear and semi-linear. Now we will write down the first order partial differential equation, which is linear in nature. So linear first order partial differential equation, and let us say that a general form can be written like this: aux plus buy plus cu is equal to some function fxy. And here a, b and c, they are the coefficients of the unknown function and its derivative. They can be function of x and y only, they cannot be function of u. Otherwise, it will become non-linear. So when we say that it is linear, so it is clear that a, b and c, they can be functions of x and y. They can be function of x and y. Now, the solution of such a partial differential equation can be discussed in two ways. So one is either b is 0 and another is if b is not 0. So if b is 0, that means the partial derivative of the unknown function with respect to u is 0. So if b is 0, that means this partial differential equation will be converted into this form: plus cu is equal to fxy. We can see that it is quite clear that it involves only the partial derivative of u with respect to x by treating y as constant. So it can be dealt in the way in the similar manner where we have how we have dealt the ordinary differential equation of first order. So we can find out the integrating factor. That integrating factor will be multiplied both the sides, and then rest of the procedure will be similar like we have solved the first order ordinary differential equation. Now when b is not 0, then that means the equation involves both type of derivatives ux and uy. In such a situation, we have to make some substitution, and by that substitution we are going to change this independent variables from x and y to w and z. So let us say that w is bx minus ay and z is y. So after making these substitutions, this entire partial differential equation will be converted into a more convenient form where we can use the techniques of which will be similar to the ordinary differential equation, and this partial differential equation can be solved. So with this substitution, we will convert this x and y in form of w and z. So basically the aim of the substitution is to convert this partial differential equation into a simpler form to solve. So we'll see that if we solve these two, then this x will be written, y will be written as z clearly from this one. So it will be w plus az divided by b. So this will be the substitution for x and y in form of w and z. So we should know this thing, we should remember this thing, that we are making this substitution to convert our set of independent variables, that is x and y, to another set, that is w and z. So we'll make it more clear by taking one example. Okay, so we'll make the second method clear by taking one example. So we'll take this question. Find the general solution of the linear partial differential equation 3ux minus 2uy plus u is equals to x. So here this b is not 0, that is the coefficient of uy is not equals to 0, therefore we need to solve it by second method. So we need to apply the second method where b is not equal to 0. So we'll compare it with this form aux plus buy plus u is equal to cu is equal to fxy. So here a is equals to 3 and b is equals to minus 2. Since b is not equal to 0, so we'll use the second method where we need to substitute this x and y for w and z. So we are going to use this x and y. We are trying to convert them in form of w and z, where z is y only and w is equal to bx minus ay. So from this, y will be written as z and x will be written as, from this it is clear that w plus ay divided by b. Now here b is minus 2 and a is 3. So we are going to substitute those values to get the exact form of x and y in form of w and z. So it becomes w plus 3z divided by minus 2 and y is equals to z. So this is minus 2. So this will be the substitution we are going to use to solve this differential equation. Since we are going to substitute w and z in place of x and y, therefore let us say that earlier the unknown function was uxy and now the new function will be vwz. So we will see that how these partial derivatives will be changed. So ux, that is del u by del x, will be changed. We need to change that in terms of this v. So here we will use the chain rule. So this is del v by del w and then del w by del x and then del v by del z and del z by del x. So we already know the relation of w and z in form of in terms of x and y. So on substituting the values of a and b in this one, so it will be w is equals to, so the value of b was minus 2, so it is minus 2x minus 3y and z is y only. So from this we can see that del v by del w and del w by del x. So from this we can see that del w by del x will be minus 2. So it is minus 2, and plus, since z is function of y only, so this derivative is going to be 0. So del v by del z into 0. So this becomes minus 2 del v by del w. Then we will be getting this second partial derivative, that is uy, that is u with respect to y. So if we get this, we will get del v by del w and del w by del y. Then v is a function of z also, where z is a function of y also. So we'll write this. So it is del v by del w. So from this del v by del w will be written as it is. Del w by del y will be minus 3 from this. Del w by del y is minus 3. So it is minus 3. And plus del z over del y will be 1 from this one. So it is del v by del z into 1. So therefore this uy becomes, so if we write this del v by del w as vw and del v by del z as vz, so we can make this notations. So del v by del w can be written as v the subscript as w, and del v by del z, these are the notations we are going to use for this. So this is vz. So we're going to get this u in terms of minus 3 vw plus vz. And from here we are getting this for vx. Clear? So we are getting this ux as from this one minus 2 vw, and that's it. So if we are going to replace this in the given differential equation. So our given differential equation was 3ux minus 2uy plus u, where u was the function of xy, is equals to x, which will be converted to a second type of differential equation, partial differential equation, which is having a unknown function as v in place of u, x and x and y has been replaced with w and z. So 3ux, 3 into minus 2vw minus 2, this uy can be written as minus 3vw plus vz and plus v, and this we cannot leave this x as it is, we need to replace it with the same substitution. So from here we can see that this x will be replaced with this one, w plus 3z divided by minus 2. So w plus 3z divided by minus 2. Now this is the common mistake, that we leave any of the x and y present in this differential equation. Please try to understand that given differential equation was independent variables were x and y and the unknown function was u. Now it has been a changed differential equation, where the changed differential equation should be written in terms of w and z as your independent variables, and now the unknown function is v. Therefore, we must ensure that the changed differential equation must not contain any of the independent variable out of x, y or u. Therefore, this is the changed differential equation. So if we write this minus 6vw plus 6vw minus 2vz plus v is equals to w plus 3z divided by minus 2. Now this gets cancelled, and this is not by mistake, this is because of this substitution. They will always be cancelled, either this one or this one. So now the differential equation has been converted into 2vz minus v is equals to w plus 3z divided by 2. And you can, it is clearly visible that the differential equation now involves the partial derivative of v with respect to one variable only out of the two that were the w and z, and now it involves the partial derivative of v with respect to z only. So this case 2 where b is not 0 has been converted to case 1 where b was 0, and now since it will be dealt in a similar manner like we have dealt with the ordinary differential equation of first order. We will find out the integrating factor for this, we'll multiply both the sides by the integrating factor, and then we'll be able to find out the solution in terms of v. But remember, here the solution of this differential equation will be, we will be getting v in terms of, let me say that g as w and z. But then we need to, this is the unknown function, and this is, let us say, the function which we will get after solving this differential equation. Now we need to reconvert it into the original form. So the original set of independent variables were x and y. Therefore, we cannot leave our solution in this form. We need to change it back by making this u in terms of xy, and this will be, let us say, some hxy. So such a function will be written as in term for the solution of the given differential equation. So what is the strategy? When b is not 0, we are making the substitution. We are trying to convert this set of independent variable from xy to wz by making this substitution. W is equal to bx minus ay and z is y. So by this substitution, this partial differential equation where it involves both the partial derivative with respect to x and y will be converted into a first order partial differential equation where the partial derivative with respect to one variable only will be involved. And that can be dealt easily because we have already dealt with the ordinary differential equation of first order. So I'm sure it should be clear to us, and we can solve this question completely by taking this example as first order partial differential equation. So we have learned that what is the need of partial differential equation, because any situation is depending on more than one independent variable. So whenever it is depending on more than one variable, then we cannot take the ordinary derivative, we have to take the partial derivative. And when any equation involves partial derivative, the unknown function, and its independent variables, then that is called the partial differential equation. Then we have learned that what is the order of partial differential equation, classification of partial differential equation in terms of linear, non-linear, quasi-linear, semi-linear, and then we have learned how to solve a linear first order partial differential equation if it is given in a simple form where b is 0 and where b is not 0.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.